Today we'll be working on Lesson 11 Membrane Switch Module. For this lesson we'll be needing the Elego Mega 2560R3, the Membrane Switch Module, and 8 M2M jumper wires. Let's check out the lesson plan. The lesson starts off with the objective, which is integrating a keyboard with an Elego Mega 2560R3 board, so that the Mega 2560R3 can read the keys being pressed by a user. For this project we'll be using a matrix keyboard. This is a keyboard that follows an encoding scheme that allows it to have much less output pins than there are keys. The wiring diagram is as follows. We'll be using the D2 PWM all the way up to the D9 PWM to connect to the matrix keyboard. We'll talk about those connections in our next section with the coding diagram. The coding diagram starts by including the keypad.h library, this guy right over here. So I'm going to just show you how to do that real quick. We're going to go over to Sketch, Include Library, Add .zip library. We're going to find our master file, Elego, the most complete starter kit. We're going to walk through this until we get to English, Code, Lesson 11, Keypad. And then we're going to click Open. I've already done it, so I don't want to mess it up. Let's keep going. Next, we get to constant byte rows and constant byte columns. So a constant byte stores an 8-bit unassigned number from 0 to 255. This will assign the rows and the columns. Next, it defines the symbols on the buttons of the keypads itself. Char, hexakeys, rows, columns equals brackets. Now this sounds really confusing, but I'm going to try to explain this to the best of my ability. So char equals characterize, hexakeys just means 16 keys, and now we're going to be defining the symbols on the buttons of the keypads. Well, there's just one keypad in this instance, but... Now, rows are horizontal arrangements. Columns are vertical arrangements. So vertically, we have 1, 4, 7 star, and horizontally, we have 1, 2, 3, A. And this is how this is characterized. Now, this next set of code, byte row pins rows, and byte column pins columns, equals these two sets of our PWMs, essentially just connects the row pinouts of the keypad and the column pinouts of the keypad to our Arduino. And that's how we're able to speak to it. Next, we'll be initializing an instance of class new keypad. So keypad custom keypad equals keypad, brackets, make key map, and now we're creating the key map. I know this sounds really confusing, but hexakeys, which is our 16 keys, row pins, column pins, rows, and columns. So all we're pretty much doing is just compiling all of the data that we typed out earlier and creating our keypad custom keypad. Void setup serial.begin 9600 just sets the frequency to which we will be communicating with the serial monitor. Void loop characterizes custom key to equal custom keypad.getKey. And what that does is it takes our custom keypad that we created over here and it allows us to get inputs. It allows us to get outputs from our inputs. And then if custom key is selected, like we get a key, it'll print that on serial monitor and it'll print ln, which means it'll print line by line. Okay, so now with all of that out of the way, let's build it.
Godlow on the track.